Welcome to the Cloud Data Integration, RunTime Environments course. Hello. Through this training. Up in the right-hand corner, you'll notice a resources area. These resources will supplement and support this course. At the end of the training, there is a quiz. This quiz is designed to provide direct feedback on your knowledge of the content presented. You are always welcome to go back and review any of the information presented in this course. At the end of the course, you will be presented with a survey. Your feedback is critical to the success and further improvement of our courses. Please take a moment to complete this very important step. Now, let's move on to the objectives for this course. The objectives of this course are: understand the various runtime environments available. Understand the benefits and limitations of local secure agents. Explain advanced integration using Kubernetes in a cloud ecosystem. And explain the advanced serverless environment. Welcome to the Runtime Overview module. IDMC offers various options for runtime environments based on the customer's requirements. The basic runtime environment is a secure agent running cloud data integration. Secure agents are hosted on premises or on cloud servers in the customer's cloud environment. These secure agents provide codeless data integration, executing the tasks and mappings developed. The customer manages the number, size and location of the secure agents. You can use the hosted agent to run tasks if the customer has a cloud runtime license. Informatica maintains this agent, and it is typically used for scenarios where source and target data reside in cloud applications and infrastructures. If access to local applications is needed, you must configure the firewall rules for hosted agent, or install a secure agent within the customer's network. For increased scalability, CDI Elastic was introduced a few years ago. The mappings are translated into Spark code, which is then executed on an Elastic cluster in the customer's cloud environment. The customer must install a secure agent on a Linux server in the cloud and set up the Elastic cluster in the IDMC administrator. IDMC will spin up compute clusters when needed using this environment. CDI and CDI Elastic mappings can both be executed in an advanced serverless environment. Informatica completely manages the Elastic compute cluster, using the Informatica infrastructure to spin up the compute clusters. There is no need to install a secure agent, although you will have to create a VPC in the customer's AWS environment. When you are ready, please move forward to the next section. The Cloud Secure Agent is the local runtime environment installed on Windows or Linux. Refer to the product availability matrix on the support website to check which versions are supported. You only have to install the secure agent, upgrades will be done automatically. The secure agent checks whether updates exist for the installed services and will pull them from IDMC. There is no need to manually install or apply new versions. A secure agent group consists of one or more secure agents, to enable high availability and load balancing. You can also use secure agent groups to separate runtime environments for different departments or enabled services. Because the secure agent is installed behind the customer's firewall, it can access all local databases, file systems, or applications without opening ports in the firewall. The secure agent can be installed locally on physical or virtual servers. You can also install them on servers in the customer's cloud environment, like AWS, Azure, or GCP. This is useful to access file systems like S3 or ADLS, or databases like RDS or Synapse Analytics. Capacity and performance depend on the size and number of secure agents installed. If you need more power, you can scale horizontally by adding more secure agents, or vertically by using bigger servers with more memory, CPU, and disk space. The Informatica Cloud-hosted agent is an out-of-the-box runtime environment for integration. It is separately licensed, so it will not be available at every customer. You cannot configure this agent to add or remove services, connectors, or custom options. The Informatica Cloud-hosted agent is typically used for cloud-to-cloud integration, for example, to read and write to Salesforce.com or Workday. It is mainly used in cloud application integration, where processes will use APIs and web services to interact with other applications. These are some advantages and limitations of working local using the Cloud Secure Agent. The secure agents initiate all communication with the IDMC org, so from a network security perspective, no incoming traffic is needed. This reduces the complexity of firewall configurations. Many customers still use on-premise legacy applications, databases, and file systems. Having a local secure agent eases access to these environments. However, there are also limitations. First, the performance is limited. Especially for large data volumes, even with multiple secure agents in a group, there may be limitations in capacity. Scaling up the environment requires extra hardware. It is also complicated to scale up at peak times and down when there is little or no demand. And, although the cloud secure agent is upgraded automatically with new versions, the hardware maintenance and upgrades may be complex to manage. To overcome these limitations, Informatica has introduced advanced integration and advanced serverless. These two topics will be discussed in the next modules. Welcome to the Advanced Integration module. Advanced integration was formerly known as CDI Elastic. It allows for greater scalability than the traditional secure agent groups, by using Kubernetes clusters in the customer's cloud ecosystem. The Kubernetes cluster provides a distributed processing environment with optional auto-scaling to support any size of workload, all within the boundaries you specify. Cloud ecosystems supported for advanced integration are AWS, Azure and GCP. You register an advanced cluster in the IDMC administrator. Prerequisite is to have a cloud secure agent running on Linux. This secure agent leverages the Kubernetes cluster to process the data logic. To use the advanced cluster, you build a mapping in advanced mode. When executing the mapping, the processing logic is translated to Spark and sent to the Kubernetes cluster. The Spark tuning process analyzes the data size and cluster capacity to auto-tune the processing in the Spark engine. So, how does it work? First, the cloud administrator creates the advanced configuration. The first step is creating the secure agent on Linux, the second is registering the advanced cluster in the IDMC administrator. The developer creates a mapping in advanced mode, with the required sources, targets, and business logic. Create a mapping tasks and task flow, or run it manually. The mapping is pushed to the cloud secure agent, which creates a Kubernetes cluster or connects to an existing one. The mapping logic is translated to Spark and executed on the cluster. The secure agent collects and reports the execution statistics, which can be monitored by the cloud administrator to check for activity and cluster health. There are three types of advanced cluster. Let's begin with the fully managed. The fully managed cluster provides a serverless infrastructure that intelligently scales based on the workload. It offers the lowest total cost of ownership of the three types. The secure agent manages the entire Kubernetes lifecycle, including cluster startup, shutdown, auto-scaling, and upgrade. Auto-scaling scales the cluster up or down based on the workload size and the resource boundaries specified in the customer's cloud ecosystem. Jobs consume fewer resources during smaller workloads, and it will scale up when the workload increases. The cluster only consumes resources when you are running jobs. The secure agent manages the shutdown based on the method selected in the advanced configuration. Claire, Informatica's AI engine, uses machine learning to auto-tune the jobs running on the cluster to achieve optimal performance. The Spark performance tuning process analyzes the data size and cluster capacity to auto-tune data processing on the Spark engine. High availability, recovery, and resilience ensure that jobs can continue running smoothly during interruptions. The self-service environment gives you more control over the Kubernetes cluster. Unlike the fully managed clusters, the secure agent does not create the Kubernetes cluster, but uses one created by the administrator of the cloud ecosystem. This gives you more control over managing permissions, authority configuration, and resource limits. When an advanced mapping is started, the agent pushes into the Kubernetes cluster. The cluster then leverages the Spark engine to process the data logic. The self-service cluster doesn't auto-scale the cluster nodes, it uses the available cluster settings as defined in the cloud ecosystem. On shutting down the cluster, the secure agent removes all Informatica resources from the Kubernetes cluster, but the environment stays intact. The main advantage of using a self-service cluster is having more command over the cluster control plane. You have full access to the cluster and can master all the other related management components. You also have more control over the deployment and administration of your cluster. The local cluster is a single-node cluster, running on the machine where the Cloud Secure Agent is installed. Therefore, you have limited capacity, and there is no scaling. Although it is called local, the cluster must run on a cloud environment. Supported are AWS, Azure, and GCP. A local cluster is typically used for testing functionality with smaller amounts of data, where the computing power of a Kubernetes cluster is not needed. Time for some exercises. In the following 2 labs, you will walk through the installation and registration of an advanced cluster and run an advanced mapping to see the Spark processing. Click on the buttons to start the exercise. After you have completed the labs, please move forward to the next section.
In this exercise, you will walk through the setup of a local advanced cluster. The local advanced cluster is a single-node environment, which can be used for testing functionality or loading smaller data volumes. Here you are in the AWS EC2 page, where you can manage instances. An instance is a virtual machine running in your AWS environment. The instance name is RHEL, short for Red Hat Enterprise Linux, and you see the internal instance ID. Click on the instance ID to view the details. At the bottom of the screen, you see the platform details. As per the April 2023 release, only Red Hat Linux is supported for the local advanced cluster. Always refer to the product availability matrix on the support page for supported operating systems and versions. You also see the public IP address for the machine to enable terminal access. Let's have a look on the Linux box. Click on the terminal icon in the Windows toolbar. At the bottom of the screen, you see the platform details. As per the April 2023 release, only Red Hat Linux is supported for the local advanced cluster. Always refer to the product availability matrix on the support page for supported operating systems and versions. You also see the public IP address for the machine to enable terminal access. Let's have a look on the Linux box. Click on the terminal icon in the Windows toolbar. The Cloud Secure Agent is already installed. Its location is /opt/infagent. The folder structure is the same as in Windows, with all enabled services shown in the Apps folder. Click the command line to continue. The Secure Agent is running, shown here using the PSF command. For more information about the installation of the Secure Agent on Linux, refer to the Implementation Advanced topic, Secure Agent on Linux. Click the command line to continue. When the Advanced Integration license is enabled in your IDMC org, the binaries will be installed in the @_scale_server folder, as shown here at the top of the screen. The installation always has a version number, in this environment 42.0.2.1. One folder to remember is ccs_home. Here you will find the ccs operation.log file. This is your starting point for debugging any issues with the advanced cluster. Click the command line to continue. This is the IDMC administrator. On the RunTime Environments page you can see the Secure Agent running. Click the Advanced Cluster tab on the menu on the left to see the advanced cluster. Installing the Linux Cloud Secure Agent in a supported cloud ecosystem automatically creates the default advanced integration cluster you see here. But before you can use it, you need to configure a few things. Click on the cluster to configure. Here you see the configuration page. The runtime environment is set to the secure agent on AWS, and the cloud platform is local. In the platform configuration, the default values for the staging location and log location are two environment variables on the Linux box. You can set these in the user profile on Linux, or, like here, enter the absolute file path to the required locations. This concludes this short exercise about the advanced cluster configuration. In the next lab, you will run a mapping on this environment. Click Next to go back to the presentation. The mapping shown here is an advanced mapping. You can see it on the top of the screen with the purple mark Advanced. An advanced mapping doesn't say anything about its complexity, it is just the terminology used to indicate a mapping executing on Spark in the advanced cluster. The mapping reads a file from the S3 file system, and writes it to another location in S3. Click the View button next to the connection field to view the source connection. These are the connection details. The runtime environment is the secure agent on AWS, which is connected to the advanced cluster. Lower down on the page you see the S3 access and secret keys, and folder path. Click Close to return to the mapping. For this mapping, a mapping task is created, specifying the runtime environment. Click on the mapping task on the left-hand side of the screen to view it. The runtime environment shows the secure agent on the AWS environment. A standard mapping would execute on this secure agent, but an advanced mapping will initiate the Kubernetes cluster for execution. Click Run to execute. A pop-up comes up, saying the mapping run has started. Click the My Jobs text in the pop-up to monitor. The status is shown as starting. Click the refresh button just above the status column. The third tab in the browser is for the IDMC monitor service. Here you can monitor jobs, check all kinds of logs, and check the status of advanced clusters. Click on the tab to go there. The advanced cluster is still starting. It takes a little while before the Kubernetes cluster is up and running, but that overhead is minimal when processing large volumes of data. Return to Data Integration on the leftmost tab of the browser. The mapping task is now running, and you see one subtask. This means the mapping logic is now translated to Spark code and executing. Click on the subtask to see the details. The subtask is called InfoSpark 0, indicating the Spark code is executing. Click on the subtask to see more. Click Close to close this screen. To close the subtask, click on the blue Data Integration text in the screen header. Click Refresh to check whether the status has changed. Click Download to download the session log. More information about the run is available in the InfoSpark 0 subtask. Click on the subtask to view the details. At the bottom of the screen, you see the run statistics. The job has read 1000 rows from the input and written the same amount to the output file. You can download the driver and agent log files here. These may be useful for debugging any issue. Click Download to download them. You see the downloaded files at the bottom of the screen. There is no need to open them in this exercise. This concludes the lab. Click Next to return to the presentation.
Welcome to the Serverless Environment module. What is serverless computing? A good test for serverless is never having to manage infrastructure, never having to patch the operating system, never needing to upgrade software, never having to worry about scaling or elasticity, never having to pre-provision infrastructure, never having to pay for idle infrastructure. The three major cloud vendors AWS, Azure, and GCP offer true serverless in their infrastructure as a service architecture. However, few services outside these three are really serverless. As discussed earlier, Cloud Data Integration offers cloud-native and codeless data integration. The customers need one or more cloud-secure agents to process the data. These can either be on-premise or hosted in a cloud environment. Advanced integration adds Spark processing with auto-tuning and scaling, using a Kubernetes cluster. The customer needs a cloud-secure agent installed in their cloud ecosystem to leverage the Kubernetes cluster to process the data. Informatica's advanced serverless deployment fully manages the environment with no clusters or software to install or manage. It offers high-performance data integration with built-in elasticity. Advanced serverless can run processes in both CDI and advanced mode. As of April 2023, advanced serverless is only supported on AWS. Let's explain the working with a diagram. This is the IDMC environment, with a repository for storing the metadata. The IDMC environment is multi-tenant. The serverless environment uses an isolated, single-tenant model, with a dedicated server to manage the tasks. This tenant resides in a DMC, and all inbound communication is denied. It auto-scales with the size of the workload. Here is the customer's AWS environment with the necessary services available. The customer's tenant in the IDMC environment connects to the customer's AWS using an Elastic Network Interface, or ENI. This ensures secure communication between the two. Access to on-premise or SaaS database and applications is controlled by the customer AWS environment. All communication from sources and targets to the serverless environment goes via the ENI. The benefits of using the advanced serverless environment are: lower total cost of ownership, a reduced infrastructure cost and footprint by having the integration environment in the IDMC tenant, reduced admin costs, everything is administered by Informatica, zero costs for idle time, the customer is only charged when processes are running, higher productivity. Developers can focus on developing the business logic instead of managing the infrastructure. No need to manage a sandbox infrastructure. No need to worry about concurrency, elasticity, etc. Business agility. Jumpstart integration projects because time-consuming infrastructure provisioning is not needed, so that the project can focus on development and business logic. This will result in faster time to market. Operational simplicity. Lower operational overhead by reducing infrastructure setup, configuration, provisioning, and management. Built-in elasticity and scaling easily addition of new integration projects. Before creating the serverless environment in IDMC, you must first configure the customer's AWS environment. This diagram shows the various configurations necessary. A VPC, containing the data to process. A security group. A private subnet to host the Elastic Network Interface. A public subnet to provide internet access. An IAM role, allowing access. VPC peering to connect across VPCs. The ENI, the Elastic Network Interface. The RunTime Environments manual discusses the details. You can find it in the resources section for reference purposes. Before setting up a serverless environment, download the latest version from the Informatica website. You can do this configuration manually or use a CloudFormation template. This template will configure all the necessary resources and create the configuration file for the serverless environment. Use this file to create the environment in the IDMC administrator. Time for some exercises. In the following two labs, you will set up the AWS stack to allow the serverless environment to execute and then register the serverless environment in IDMC. Click on the buttons to start the exercise. After you have completed the labs, please move forward to the next section.
This exercise will show you how to configure AWS to enable advanced serverless environments, using a CloudFormation stack. Usually, the AWS administrator will execute these tasks, but getting insight into the steps and assets created in AWS is helpful. Here you are on the Serverless Environments page in the IDMC administrator. You already see two serverless environments created. This may be a common scenario when a customer has multiple cloud environments and wants to use serverless for all or some of them. So, let's create a third one. Click on the New Serverless Environment button at the top right. Select the second option, Request a configuration file from your cloud administrator. Select the region where you want to create the AWS stack. Your AWS administrator has given you the region US East Ohio. Click on this region in the pull-down menu. The wizard creates a draft email you can send to the AWS administrator. It contains two links to create the stack, one on a new VPC and the other on an existing VPC. The text for a new VPC is highlighted here. Click on the text to copy it. Let's pretend you are the AWS administrator. You have received the link and want to create the stack. Click on the New Tab button in the browser to open a new tab. After you have pasted the link into the address bar, the following screen comes up. This screen shows you are in the Create Stack function in the CloudFormation tool in the AWS console. Some options are pre-configured, like the VPC settings at the bottom of the page. First, give the stack a name by clicking on the name field. Click the scroll bar on the right to scroll down. For this exercise, the VPC settings you just scrolled past can be kept default. One important setting is the supplementary file location. This location will store the stack configuration you will create. It will also contain any external binaries, like Java or Python executables, you want to use in an advanced mapping. Click on the supplementary file location to enter the S3 bucket name. Ensure you have entered a bucket name and not a folder within the bucket, otherwise the stack creation will fail. Click on the scroll bar to scroll down to the bottom of the configuration page. Almost there. You see two messages about creating an IAM resource and the auto expand option. Click on the first one to acknowledge. Both are acknowledged, so we're ready to go. Click Create Stack to start the creation. Creating the stack will take 5 to 10 minutes. When it succeeds, you see 5 stacks created, 1 main stack and 4 nested. The process has also created a configuration file in the supplementary file location. You will use this file to register the serverless environment in IDMC. The third tab in the browser shows the S3 bucket. Click on it to go to S3. This is the S3 bucket, and the process created a folder called IICS sreconfig. Click it to open it. Click the folder to open it. The JSON file here contains the configuration. Click Download to view the contents. Click on the file name to open it. The JSON file contains the internal IDs of the assets created. When you create the serverless environment in IDMC in the next exercise, use this file to load the configuration. This concludes this exercise. Click Next to return to the presentation. In this exercise, you will use the configuration file created in the previous lab to register a serverless environment in IDMC. The starting point is the same, the Serverless Environments page in the IDMC Administrator. Click the New Serverless Environment button at the top right to begin. Select the first option, Create a serverless runtime environment. The new serverless runtime environment page comes up. Click the Import Configuration button to use the JSON configuration file. Click Choose File. In the Explorer, highlight the file to use. Click Open. Click Import to use the file. You see the imported settings in the platform configuration at the bottom of the screen. Click the Name field at the top to name the environment. Click the Description field to give the environment a meaningful description. Click the Task Type field to view the options. The two options are Data Integration and Advanced. If you want to run standard mappings, choose Data Integration. For advanced mappings, choose Advanced. If you want to run both on the serverless environment, you create two environments using the same configuration file. For his exercise, click Data Integration. Click the Max Compute Units per Task field to see the options. This indicates the maximum resources a task can use. Set it to 1. In the bottom half of the screen, click Configuration Name. All done. Click Save to save the configuration. After saving, you will return to the Serverless Environments page. After a few minutes, the environment will be up and running. This concludes the exercise. Click Next to return to the presentation.
Cloud Data Integration, Runtime Environments, Summary. In this course, the following topics were covered. The various runtime environments. Benefits and limitations of local secure agents. Advanced integration environments. And advanced serverless environments. Now, it's time for some review questions. Topics covered by the Cloud Data Integration series include Concepts and Architecture, Predefined Tasks and Mass Ingestion, Runtime Environments, Mapping Design and Development, Parameters and Dynamic Mappings, and Hierarchy Processing. There will be a comprehensive assessment at the end of the 6 courses. You must score 80% to pass the Cloud Data Integration series. Thank you for completing the Cloud Data Integration, Runtime Environment course. Please click the Exit button to complete this training.